It's now my pleasure to welcome the Keenan Institute of Private Enterprises Chief Economist Gerald Cohen, who's going to be moderating a wonderful panel discussion on Can Entrepreneurs Save the Planet? So Gerald holds a Bachelor of Science from MIT and a PhD in economics from Harvard. He is uniquely qualified to moderate this panel. It's a terrific panel. So Gerald, I'm going to pass the virtual baton over to you. Take the floor, my friend.
Thank you, Chris. So I have the unenviable position of trying to solve the world's problems with entrepreneurs over the next 40 minutes, which seems like a difficult challenge, but as you'll hear in a moment, the panel that we have put together, I think is definitely up to this challenge. So as we all know, society faces a series of major problems such as climate change, which require transformational technological change as part of the solution. Many of these problems are so large and complex that it seems unlikely that entrepreneurs working in their garages are going to solve these alone. So this raises the question of how to create the right ecosystem to foster these solutions and to go from government and university labs to entrepreneurs to large-scale production. And in particular, what research backbone, human, physical, and financial capital, as well as incentives do entrepreneurs need to take on these complex problems? And as previous sessions have noted, how we can do this in an equitable way. Fortunately, we have two experts in the field, in particular, the clean energy space, to help us answer these questions and to tell us what has worked, what hasn't, what has been tried, and what should be tried. Jacquelyn Pless is the Fred Kane 1960 Career Development Professor of Entrepreneurship and Assistant Professor in the Technological Innovation, Entrepreneurship, and Strategic Management Group. That's quite a handful at the MIT Sloan School of Management. Her research explores the drivers and consequences of innovation for social projects through an economics lens, with a particular focus on understanding how policy and management can drive clean energy innovation and innovation that protects environmental systems more broadly. Prior to joining MIT, Jacquelyn held positions at the University of Oxford, the National Renewable Energy Laboratory, the National Conference of State Legislatures, and the World Bank. She holds a PhD and MS in Energy Economics from the Colorado School of Mines and a BA in Economics and Political Science from the University of Vermont. Dr. Eric Toone leads science, technology, and engineering at Breakthrough Energy Ventures. Prior to BEV, Eric was a member of the Faculty of Chemistry at Duke University and is the former director of DOE's Advanced Research Program Agency, DARPA, which Eric will talk about. A technical lead, Eric is responsible for overall technical direction of the organization, with responsibilities ranging from thesis development to technical diligence. Originally trained as a bioorganic physical organic chemist, Eric has long worked in both exploratory science and the translation of that science to practical implementation. At Duke, he authored 300 papers and abstracts, and from 2012 to 2016, he served as vice provost and director of Duke's Innovation and Entrepreneurship Initiative. He's also a listed inventor in over 30 patents and the founder of 3 venture-backed pharma companies. I feel a little bit like the referee at the Bills-Chiefs game, where I'm on the field with 2 supercharged, and that pun was intended, researchers, but it's a collaborative game. So Eric won that coin toss. So Eric, the floor is yours.
Thanks very much, and it's great to be with you. I wish we were doing this in person, but again, hopefully we can do that next year. I want to just make a few introductory remarks, and let me tell people ahead of time where it is that I'm going with these remarks and the point that I want to make. The federal government spends about $150 billion a year in research, a little more than half of that on non-defense spending. That money is split roughly evenly between basic research, applied research, and development. But if I look at the sort of overall scheme, if I look at the total economy, the federal government's responsible for about a half of all basic research that's done in this country, about a third of the applied research, and only 1/10 of the development. And that reflects the fact that the federal government has an important and an appropriate role in the creation of knowledge. As that knowledge turns into applied knowledge, and eventually into products that make their way into the marketplace. Because remember, after all, that $150 billion comes from real people, from taxpayers who are giving that money because they want to support the activities of these federal agencies. As we get closer and closer to market, the government's role becomes less appropriate. Federal government doesn't pick winners and losers. We have a marketplace that does that. But near the boundary of where the federal government has an appropriate role and where the marketplace is willing to pick it up and advance it towards practical application, there is a broad chasm. And that chasm has grown only wider over the past decades. And I'd like to argue that on both the public sector and on the private sector side, we need new types of vehicles, new types of investment agencies that are capable of bridging that gap. So, can the government foster technology development? Kind of an interesting question. We know they can do basic science. Can they do technology development? 1956, the Soviets launched Sputnik and scared this country to death. We were losing the race for space. We were falling behind in a desperate race. And so in response to that, the Congress of the United States created a new agency, the Defense Advanced Research Projects Agency, or DARPA. And DARPA is sort of legendary in the field of funding and of fostering innovation, and has created some of the most impactful innovations that we have today. And there's a great Bill Bonvillian from MIT has spent a lot of time working in and around DARPA and wrote a wonderful treatise about the role of DARPA and why it works so efficiently. And you can kind of go through the list of attributes that an agency like this that is designed to foster innovation should be. Small and flexible, flat, right? The joke was that DARPA was 100 geniuses connected by a travel agency. And the idea is that you fund people to turn ideas into action, obviously actions that would be of value to the Defense Department and the defense industry. But as I mentioned, there were an incredible number of innovations that came from DARPA that have profound applications in the civilian world. ARPANET was one of the progenitors of the internet, in electronics, in aviation, robotics, sort of you name it, DARPA has had a role. So DARPA was certainly very effective and valuable in fostering innovation and in the development of real applications in the context of defense. An interesting question was, is that model of innovation and of government sponsorship of innovation applicable in fields outside of defense? And so, especially during the Obama administration, there was the birth of a large number of agencies that were designed to be like DARPA in the way that the organization operated, but focused on other areas. And so, as Gerald mentioned, the first time I left Duke at the beginning of 2009 was to help stand up a new agency in Washington to see if that approach to technology development could be applied to the energy sphere. So the Advanced Research Projects Agency for Energy, or ARPA-E, grew out of a National Academy's report, the Rising Above the Gathering Storm report. In 2007, Congress took a whole bunch of the recommendations from the Gathering Storm report, including the recommendation that they create an ARPA-E, a DARPA for the Department of Energy, rolled them up into a piece of legislation called America Competes, and passed that. And that was the authorizing language for ARPA-E. The agency was funded for the first time in the spring of 2009 under the Recovery Act, a $400 million appropriation that got the agency off and rolling. We made the leap into a regular appropriation in FY11. Today, the agency has a budget of nearly $500 million and has funded hundreds of proposals and technologies, many of which are now at market. So I think that the answer to that question was, yes, there is an approach, there is an opportunity to use the DARPA model, right, which takes people from universities, from the private sector, not career feds, and puts them in a position to, in a very active way, foster entrepreneurship, foster the transition of technology from the realm of basic science and into the realm of practical application. But there's still a big gap in the middle, right, between where the federal government is ready to fund things, or up to the point where the federal government is ready to fund, is capable of funding things and can fund things and should fund things, and where the private sector will pick things up. The days of the Bell Labs, the days of great industrial research and innovation are by and large over. And today, corporations are focused on quarter over quarter profits, and something that's 2 quarters or 3 quarters from market is just too far. So there remains in the middle here a pretty big gap. So how do we fill that gap? Well, one of the ways that we can fill that gap is with venture capital, right? Venture capital has been incredibly powerful in advancing some of the most impactful companies that exist on this planet today, right? The Amazons and the Alphabets and the Metas, all of those things, were developed by Silicon Valley through venture capital. And so into this realm in the first decade of this century comes venture capital to try and apply what had been done so successfully in other realms to energy. And it was an absolute, complete, total disaster. And somewhere between 25 and $50 billion disappeared down rat holes, and the failure rate went basically to 100%. And Frankie O'Sullivan and some of his coworkers wrote a great report out of MITI, the MIT Energy Initiative, about exactly what went wrong. And basically the answer was that we tried to apply a model of tech innovation to an area where it wasn't really relevant. Let's think about how venture capital works in the tech space, right? You're out there, you see 50 new ideas, 50 bright young innovators with wonderful new ideas. 43 of those you're pretty sure are never going to work. The other 7, I don't really know. So what we'll do is we'll give them a little bit of time and a little bit of money, and we'll see what happens. And that works fine in tech, because a little bit of time is 6 months or a year, and a little bit of money is $500,000. The problem is when you go to tough tech, and specifically to clean tech, now all of a sudden a little bit of time is 5 years and a little bit of money is $30 million. And so that approach, that model just doesn't work. And so the name of the game, so now the question becomes, can we develop a new way of doing venture investing fit for purpose for tough tech broadly and for energy more specifically? In 2015, the leaders of the OECD world at COP announced Mission Innovation, which was an incredibly ambitious proposal by the leaders of the OECD world to double their country's expenditures on clean tech by the end of the decade, by 2020. At the same time and on the same stage, Bill Gates announced the formation of the Breakthrough Energy Coalition, a group of about 35 of the world's wealthiest and most influential individuals that was designed to be a private sector counterpart to the public sector mission innovation. The following year, in 2016, the group announced that one of their first activities would be the formation of Breakthrough Energy Ventures, a clean tech fund that would be funded by 21 of that group of folks, a $1 billion fund to focus on advancing technologies that mitigated the production of anthropogenic greenhouse gases. Einstein's definition of insanity, of course, is doing the same thing over and over again and expecting a different outcome. And so BEV was designed to be different in a very different way. And as you go through this, there are all sorts of important, I think, differences. So first, the fund was organized as a 20-year fund rather than as a 10-year fund, the normal time increment of venture capital. We're focused on climate. So we will invest in technologies that impact the production of greenhouse gases. We are interested in drawing other money to this space. Remember when we started this at the beginning of 2017, there absolutely nobody was investing in this space, in large part because of the disaster that occurred during the first decade of this century. And an important part of our mission was to attract new capital to this space. So we were interested in drawing others in. Scientific and technical possibility turns out to be really critical here. And so we have a group of people inside Breakthrough Energy Ventures that is different than any other venture firm that has ever been built. We have about 25 folks that are sort of core to our group. Probably 20 of those people have terminal degrees, have PhDs, science, and engineering. This is the full-on, shirt tucked into the underwear, pocket protector crowd. We're dorks and we're proud of it. And that allows us to evaluate these technologies in a way that really no other venture firm can. And then finally, we're looking to fill gaps. We're looking to invest in the hardest, most difficult areas of technology, places where other people are not investing. If there are 8 people fighting to get into a deal, that is not a good place for us to be. So as I mentioned, we invest in any area that impacts the production of anthropogenic greenhouse gases. That is very broadly electricity, transportation, agriculture, manufacturing, and buildings. The organization has grown amazingly, right? This kicked off in 2015. I was the first hire in the spring of just after Christmas, at the beginning of 2017. By the end of 2019, we had completely invested our first fund, about $1 billion, a little over $1 billion. We raised a second fund of nearly $1.5 billion, and that fund is more than a third developed now. We haven't finished the ecosystem. There are still important gaps here, and Breakthrough Energy is working to fill other parts of that gaps. We now have a fellows program for nascent technologies that gets things just started and off the ground. We are raising a special opportunities fund that'll provide follow-on funding for some of our successful companies. Breakthrough Energy Catalyst is there to help folks expand their companies as they go along. And so my point here is that there is in tough tech, in these difficult areas of technology, where the federal taxpayer has made investments. They've made investments and they're looking for a return. We need effective mechanisms to translate that fundamental research into practical application, into practical implementation. That involves things like ARPAs that push the federal government further towards deployment than they have been in the past and perhaps even are comfortable with. And it also means creating new forms of private sector capital along the lines of Breakthrough Energy Ventures that are purpose-built to meet the challenges of effective deployment of technology in tough tech spaces. So thanks very much, and I look forward to the conversation.
Well, thank you so much up front for the organizers for having me today. I really like the style of this kind of dialogue. It gives us academics kind of a chance to be a little bit more controversial than we might typically be when we're presenting specific papers. And so it's kind of a chance to vent, actually. So what I'm going to be talking about here is basically about whether or not there is kind of a case for or against whether startups can play a role in clean tech development. So when looking at some of the characteristics of the energy sector, the case for startups actually at first really looks pretty hopeless when it comes to whether it's the right form of organization for developing and commercializing clean energy tech. It's an incredibly capital intensive industry with kind of some key barriers to entry. So unlike a software company, energy technology firms typically need a lot of upfront financing. So Eric alluded to this as well. It's a highly regulated industry. So one example of why this is a challenge could be something like how utilities need to recover their investment costs. And so if they deploy a bunch of renewables, for instance, they're going to possibly need to raise the price of power that they're charging customers in order to recover those costs. And then the rate has to go through a big regulatory process. Another thing is that the social value of clean energy is higher than the private value. So what I mean here is the price you pay for gasoline at the pump doesn't reflect really how all the costs associated with using that gasoline because of the negative effects it creates for society via pollution. And so when that's the case, this is going to dampen the incentive to innovate. And I think maybe most importantly for the startup context is that they're very long time horizons. So Eric also spoke quite a bit to this in the sense that, Eric mentioned that it's kind of the scaling up challenge. And that's exactly right, that these very long time horizons make this kind of not the right setting for venture capitalists per se. So then if we take a look at the trends in clean tech startups over the past 20 years or so, things start to look even more feudal. These are two different plots from a recent paper of mine. On the left-hand side, looking at energy startups as a share of the total of startups by their founded year, and then also the amount of energy funding deals as a share of total funding deals in that year as well. And what we can really see here, so Eric mentioned basically that there's kind of a bit of a disaster around 2009 or 10. And I would basically call this a bloodbath, really what it comes down to. And so it really starts to introduce this idea of how we do need new financing models that provide more patient capital. So what we saw here is this really big influx in startups. They're receiving lots and lots of funding, and then that dropped off very, very quickly afterwards as there was kind of this burst of a clean tech bubble. So one piece actually to kind of highlight here, though, is that the grid management component, so the blue line here is clean energy, but grid management is also very, very important for the integration of renewable energy. So it's a form of innovation that still really matters here. But these companies are a bit more like software companies. They don't require a lot of upfront capital. They're kind of data analytics types of companies. They can test their technology really, really cheaply. And so for those types of companies, we do see something that's, there was this downward trend, but the funding is still kind of consistent. And so these types of companies, I think, kind of suit or are fitted a little bit more like we would typically think of a startup, at least up front. And so yet another point that would kind of make a case against startups being the right context here is that there's a lot of lingering risk aversion associated with some of the public funding that goes into these different companies, and they're kind of really seen and thrown in the media as being big failures. So for instance, Solyndra, many of you may have seen this in the media for quite a while. It was a solar panel manufacturer, one of the earliest recipients of funding from a DOE loan office program. And it received about $500 million in that loan guarantee. And then it just totally crashed, right? So it did for various reasons that were mostly related to other market conditions. But at the same time, so the same program funded Tesla with about the same amount of money in the same year or within a year or two. And certainly, Elon Musk isn't complaining today as the richest person in the world. And so the whole point of this loan program is really that, this is going to be a portfolio of different investments, and that there needs to be some type of kind of tolerance for some of those so-called failures, which I would say usually aren't even failures because you do learn from them. But there is still some kind of lingering risk aversion here on public agencies to kind of pick winners. So should startups just kind of give up? Is there no hope? So despite what I just showed you, I'm going to try to argue that actually that's not the case, and that there is a pretty strong case for startups here. So let's start here by looking at how the cost of electricity from renewable energy have actually dropped substantially over the last 10 years or so. And so a different story starts to emerge here. So this plot here is plotting the cost of electricity from different sources from 2010 to 2017. So this is basically going from the right side in 2010 to declines in 2017 on the left-hand side. And what we see here is that, and so this gray area also is what's representing the cost of electricity from dirty sources. And so we can see that basically all of these different technologies or the electricity from it were competitive with dirty energy already by 2010. So clearly something kind of worked here, right? The cost of these technologies were coming down, which usually happens by a lot of deployment of that technology and kind of learning by doing. And so despite the fact that there is this kind of commonly held view that renewables are more expensive, that's just simply not the case in a lot of different contexts, not for all, but in a lot of different contexts. And so the challenge, though, is that there really are so many different types of investments, subsidies, different factors that could be contributing to this cost decline. And while we do have a sense of how some of these programs have affected outcomes, so one example could be the California Solar Initiative, which was very successful in deploying solar, there's really still not quite enough data and evidence on what exactly it is that worked versus not. And so not to throw my co-panelists here under the bus in any way, but because ARPA-E was actually it's a huge success story in the energy context and really has done a really great job. But there's also room for improvement here for us to be able to learn more from these types of programs. So basically, there's this National Academy's report that came out not too long ago that is an assessment of the program. And essentially what ARPA-E did a great job on was gathering data kind of at that project level, monitoring internal metrics. But there's a lot less tracking and reporting on publicly available kind of high-level innovation metrics that researchers could be using to assess the programs. And then even if those metrics were available, the methods or the design of the program that was kind of designed up front doesn't allow for these investments to be studied in kind of a causal way. So what's the effect of funding on this outcome, this innovation outcome? I'm not going to go into too much detail on those methods, but I think a lot of people in the audience are kind of familiar with what it means to run an experiment is hard in this setting, still possible, but there are some other ways to get to some causal effects here. And so something that something that did kind of clearly work here is that we have had kind of substantial amounts of innovation. We just don't know exactly what it is that drove it. And so it's likely a mix of those different things. But we really just surprisingly know a little, not quite as much about what works and why. And so there's just a lot of space here to improve that. Eric spoke quite a bit about patient capital here, so I'm not going to really get into it. I just want to provide another example of a company or an organization that came out of MIT that's working to address this as well, and that's a nonprofit called Prime. It's kind of a mission-aligned nonprofit to support companies that are tackling climate change. And they're measuring their long-term success based on kind of the impact of their companies on greenhouse gas emissions reductions. I know I'm pressing up against time here, so I'll try to be quick. So finally, I just want to say that there's kind of another big economy-wide shift that's happening that's signaling that there will be an increase in demand for clean energy innovation. And that's that institutional investors are increasingly using metrics on companies, kind of long-term commitments to socially responsible investments. These are called ESG metrics, capturing environmental, social, and governance measures. And it's not just for reputation, it's because they're recognizing the very real risks of climate change. And so this is really starting to take off. There's been a huge amount of money that's being kind of allocated to these things over the last 2 or 3 years, especially. And so here, just as an example, the E component would be about companies that are working towards reducing emissions. You can think about kind of big industrial firms, even as opposed to just startups. In the S category, this is kind of the social component. This could be whether there are efforts by the company to increase diversity, or are they working specifically on a technology that's related to, say, women's health, to try to close that knowledge gap. But just to be increasingly kind of a grumpy economist here, I would say these measures, these indicators are really kind of big black boxes. They're usually really inconsistent. They're based on tons and tons of data, but aggregated up or weighted in different ways. They're measured in so many different ways across different companies. And so we really just need more detailed and standardized data to be able to provide more nuanced insight that could help inform investment decision-making. So is there a strong case? I actually would say yes, and that they're actually possibly even have some type of comparative advantage in terms of being well-placed to play the role here. And just to say that I would argue that today's bubble, or the increase in all of these investments, is just not going to burst. This is really much more about an economy-wide shift this time around, rather than it being just a hot sector. So I'll stop there. Thank you very much. And hopefully we have at least a minute or two for questions.
Thank you, Jacquelyn. I feel like I'm watching Revenge of the Nerds. So raise your hand if you're a nerd. And what's the second part of it? If you're not a nerd, you need to raise your, if your hand isn't raised, you need to raise your standards. So both of you kind of pointed to this issue of needing patient capital, or for clean tech, ultra patient capital. So the first question that kind of comes to mind is, what is the balance between patient capital and oversight? How do you get the right balance on that front?
Well, I would say the first thing you want to do is to be clear what you mean by the word patient, right? And you definitely need to be clear that, you know, the term patient doesn't imply any lack of urgency. It's incredibly urgent. It just takes when you are building, physical things at scale, it takes a very long time. So it's a recognition of the fact that it's going to take a long time, but it does not in any way imply a lack of urgency. I think that oversight is absolutely critical. And for us, oversight comes in the form, both at ARPA-E and at BEV, of carefully thought out and mutually agreed upon quantitative milestones and metrics that people need to meet by certain times to convince everyone that the technology is continuing to move towards market. And so, I think that sort of very careful and very rigorous, thoughtful and informed oversight is necessary, while recognizing that this is going to take a long time to get to deployment.
Yeah, and I'd agree with Eric, and also kind of just to continue clarifying terminology on oversight. This could be even just a matter of making sure that you're kind of gathering the right information about what is happening, what are the efforts that are being made, what are the management practices, and the outcomes. But there's certainly a balance, especially with startups that don't necessarily have tons of people with time to be reporting on a lot of different things all the time, and also where there might be a little bit more room for being particularly nimble. And so maybe there is some better research out there that I'm not super familiar with. But I think actually it's not a straightforward question or an obvious answer in terms of exactly how much oversight there should be. Somebody should study this if they haven't already. But basically, in terms of trying to figure out, should we be checking in once a month? Should I be kind of really directing their activities? What exactly is the type of oversight that leads to kind of better outcomes? So I just think that there's a lot of room to learn more there as well.
One of the great things about this conference is that we can raise questions that researchers can go back and ask. So there's a question in the chat. Do you see financial agencies like the SEC requiring specific ESG reporting metrics and regulations coming? I'm going to make a quick comment on that and say that's a great question. And it's actually something that we at the Keenan Institute are working on. We have an annual theme this year of stakeholder capitalism. And actually our next insight, which will be released in a month, is about ESG measurement and regulations or measurement issues and what's the optimal way to measure. So I'd like to ask our panelists this question and also add a question about whether are ESG funds actually patient enough to be or I should say, are ESG funds that have a retail bent patient or report to retail patient enough to be actually good investors in the clean energy space? So
I can jump in here after talking about ESG metrics. And thank you for the question. I find the question around reporting requirements to be super important. So at the moment, or at least historically, a lot of the reporting has been voluntary and really just targeted towards a certain set of companies, as opposed to being kind of universal. But there has really been a lot of talk around what it means to start requiring that reporting and to make it a little bit more consistent. So these are two things that are really, really important to try to get this right. And we have seen, I think, across Europe, kind of a lot of these requirements starting to get implemented, a lot of talk in the US, and even at the state level, I think that there are maybe some regulations out there requiring it at the state level, but we do need it across the board. And so I would say that I'm hopeful on that. I'll try to be bullish, but who knows? I mean, we do, yeah. So who knows? Hopefully that happens. And Gerald, to speak to your question and comment, I'm really glad that you guys are working on this stuff. I know we chatted about that before. So it's really exciting. And so whether, these are kind of patient enough, I guess I view, maybe I'm wrong here, but like when I think about how investors are using ESG metrics, it's more about like the companies that they're choosing to invest in, say, even if it's not a startup, but it's some, big type of industrial firm, to assess their impact. It's just a matter of whether they are hoping that that'll, pay off in general, that's a good company to invest in. And so sometimes the patience doesn't matter as much. Or if it's towards a startup, maybe it's that's part of their portfolio, and therefore it's okay to have kind of these longer time horizons with some of them. And so yeah, I think that there's so much more to do here in terms of getting these metrics right. And so like on the reporting piece and the data, for instance, these metrics really are, there's more than 100 questions that firms are answering, that with answers that are going into this kind of big aggregated measure. And so if you really care about very specific things that you're trying to target, like climate change impact, for instance, you need that data on those specific things that they are doing in order to know if that's where you want to put your money. And as long as the company has the right kind of data analytics person and can access that granular data, I think that there really can be a lot more nuanced insight developed.
I think that the concept of measuring impact and climate impact and the production of greenhouse gases is a great one. At Breakthrough, we've said we will invest in technologies that we believe have entitlement to at least 0.5 gigaton per year of GHG mitigation, or sort of 1% of global greenhouse gases. And then usually what I tell people next is, and if you need a spreadsheet to show me how you get to 0.5 gigaton, never mind, right? Because the point is we want to tackle the big, hairy problems. The problem with measuring emissions is that there is absolutely, positively no standards anywhere about how you do it. And so we get pitched by people constantly with new approaches to measuring GHG emissions. And so it's a great concept, but the devil is really in the details. And until the scientific community or the federal government or somebody can come up with a standardized way of doing this, the number is whatever you want the number to be.
Again, back to our issue that if you need to raise your standards, and I guess that's a good grumpy economist answer, or a grumpy scientist answer. Not to make you grumpy, not to call you grumpy, Eric. One question or two related questions are about public-private partnerships to fuel support for the next generation of entrepreneurial and entrepreneurship innovation, and also, and specifically, I guess to Eric, although Jacquelyn, you could also comment. 12 or 13 years into DARPA E, what are some current success stories now? And maybe we could do this as a quick 4-minute lightning round, and then I have a quick question, or maybe a 3-minute lightning round, and then I have a quick question to follow up related to some of our equity issues. Eric, I don't know if you want to comment on successes that you can point to.
Well, there's all sorts of successes that have come out of ARPA E. We're investors in Motif, a food ingredient company that came out of an ARPA E funded program. So we didn't fund them for food; we funded them for fuels, but they've migrated and are very successful. There are a number of successful companies at ARPA E at this point, and they're the website is replete with stories, and there's a number of them that are highlighted in the National Academy's report that Jackie pointed out.
And Jackie, PPP?
Sure, I can speak briefly to that. So I find these types of partnerships and collaborations to be extremely kind of promising. And I think there's now research out there that shows for instance, how collaborations between universities or labs and startups or other types of corporate ventures can be very successful and usually kind of more successful in terms of commercializing technologies if those partnerships do not exist. So I think there's lots of examples out there. One that I could point to that I did some work on when I was at NREL was a public-private partnership called IN2, where basically brought together a national lab, a bunch of companies, different evaluation methods, and then big banks and investors. And I haven't followed up in a few years now to see what was happening with that. But early on, even there were a number of really big success stories out there. So I think that's a kind of a great avenue to be, because there's lots of just different complementary kind of skills and resources out there. For instance, if a startup kind of needs a big tech lab that they can't afford themselves to be testing their technology and such. So certainly a promising kind of model.
So finally, a lot of the speakers talked about kind of equity and entrepreneurship. And one of the things that maybe as a starting point to getting there, it's to kind of know what human capital is actually beneficial to our entrepreneurship. So instead of looking so if you look at somebody, you can look at their skill set and experience rather than other factors. So what can you tell us from the research about kind of what makes good entrepreneurs tick?
Do you want to go first, Eric?
Yeah. So, mulish obstinacy is the first thing that comes to mind, right? I mean, you have to be, absolutely single-mindedly focused on the problem at hand. Now, I don't think there's a one-size-fits-all. We have seen successful entrepreneurs that come in every shape and size, from every, corner. From every little rock that we look under, we find interesting people with interesting stories and interesting technologies, especially in this space, especially in clean tech, especially where the depth of technical expertise that's required is so deep. I would say it is rare to find all the attributes that we need in a single person. And so rather, it's important to form effective teams. And we spend a lot of our time building those teams. A sort of activity that we've found to be especially useful is we'll find an area that we're very interested in working in. We can't find a company that is in that space that we like, and so we build them from nothing. We go and we find people and bring them together and build teams. But it's sort of like an added layer of difficulty beyond some of the activities in tech, because the technical acumen or the requirements for technical acumen are so deep. We often find that teams are the way to go.
Yeah, I definitely agree with that. The technical knowledge that's just required here is so extensive and being able to communicate that's really important. And then the regulatory kind of components here require somebody that's good with regulations. And so you really just need a diverse set of skill sets. And then just to hit home this whole, every entrepreneur needs to be very kind of really, really focused on what they're doing. This might sound a little bit extreme, but I think even, more so in this space, they really kind of need to see climate change as an existential crisis, to be extremely resilient given these time horizons, be ready to wait, at least more than 10 years. And so this just really requires that much more passion, resilience, patience of the founders as opposed to even just the capital. And so kind of good, clean energy entrepreneurs are really going to believe that the world is, as we know it, is simply no longer going to exist if we don't solve this. And so the decision kind of is a no-brainer for a lot of them.
Well, let's hope that there are lots of people out there. I again want to thank our panelists, Jacquelyn and Eric, and we look forward to continuing this conversation in person soon.